In this session of ANSYS SpaceClaim course, we are going to teach you some of the most practical commands of Design tab, such as fill pattern, replace, and mirror. These are very important tools of Design tab of SpaceClaim software, and understanding and using them can be very useful for your 3D designing process. We'll start with the replace command, which I'll explain using this example. This command replaces the selected surface with another surface that you specify to the software. For instance, in this geometry, I first create a plane on one of the faces and reposition it with the move command. Then I draw a 2D sketch in the form of a spline and use the pull command to turn that spline into a surface. Now, using the replace command, I replace the cube's top face with the curved surface I created from the spline sketch. Now I'm going to explain how to use the fill pattern command. To begin, I create a 20mm x 20mm plate and extrude it by 2mm using the pull command. Essentially, I want to recreate the pin-fin heatsink that we modeled in earlier sessions with linear pattern, but this time I'll build it using fill pattern. Following the workflow from that session, I draw the circle that will act as the pin for the heatsink. As you saw in that lesson, using linear pattern, we could independently define the pattern in the X and Y directions, specifying the number of instances in each direction and the spacing between them. However, the fill pattern command has a neat capability. By specifying parameters like the spacing between features in the X and Y directions, the software automatically determines the appropriate number of instances. Based on the spacing you set, it figures out how many copies of the geometry should be created and patterned along each direction. As you can see, I used this command to create the 2D sketch of the pins. The key step now is to extrude these pins using pull. To select all the circles, you don't need to pick them one by one while holding Control. Just open the selection panel, choose Faces with same area, and then extrude them all with pull. In symmetric geometries, you don't need to submit the entire model to the solver and increase computational cost. Since our geometry is symmetric, we can obtain an accurate solution by simulating only 1/4 of it, reducing the computational expense. To do this, I define two symmetry planes as shown. Now, using what we learned about the split body command in earlier sessions, I split the 3D geometry with the two planes we created and delete the regions we don't need. This gives us a quarter model that leverages the symmetry. Now is a good time to introduce the mirror command. First, select the reference plane about which your geometry, whether bodies or faces, will be mirrored. Then, using the options provided in the command, choose the bodies or faces to mirror and apply the operation. I hope this video was useful for you. To benefit from Mr. CFD services, including simulation, consultation, and training, visit our website and contact us via these addresses.